the marbles, okay? So I'm gonna do it this way, the same way. So I'm gonna make our first little level is gonna be the same, okay? Red, blue, yellow. Those first probabilities will stay the same because we haven't drawn anything out yet, or this is our first to draw, okay? Now our second level is what's gonna change. That's what's gonna have some different values, okay? So if we've picked a red, what's the probability of getting the red again? Let's see. So Nick. So originally there were 3 out of 6 were red. Now that we've picked a red already, how many reds total are there?
So there's 3 out of 6, so that'd be 1/2. So if we've already picked one and there's 6, then wouldn't that be 1/3?
No. So we had 3 out of 6 total. That was this one, right? Now we've already picked a red. How many reds are left if I've already picked one?
What?
Minus 1 is?
Oh, 2.
Yeah. And
oh, I just said the fraction version. I thought we were still doing fractions. Sorry.
We are doing fractions.
I know,
so
but
now
I
what's
said
the total left. So there's 2 reds, 2 blues, and 1 yellow.
5. Oh, 2 out of 5.
So 2/5.
Yeah, sorry.
Is that no? It's okay. Does that make sense?
Yes.
Okay, good. Okay. Its soul is not here. Well, I'll just ask this generally. Is the probability for blue going to change?
No.
Are you sure?
Yeah. Yes, it would change because there's less marbles now.
Right. So, but there's the same number of blue, so the numerator stays the same, but it's going to be out of 5, 2/5. Let me zoom in. It's starting to get small. And our yellow is going to be the same sort of thing. There was 1 total, so, and it wasn't picked, so 1/5. Okay, we're starting to get close on time, so I'm going to go through the rest of the branches if that's okay. So there were 2 blues to start with. This is claiming that we've picked a blue. So our number of reds didn't change, but the total did. So we're going to have 3/5 of the marbles are red. We're going to have 1 less blue, so there's only 1 blue to pick from this time, but 5 marbles total. So 1/5. And then for yellow, we have 1 marble, okay? And it's out of 5. Okay, so our new denominator for this second layer of our tree diagram is going to be 5. And our very last possibility is that we picked a yellow first. The possibility of getting a red afterward is going to be 3 out of 5. The possibility of getting a blue is going to be 2 out of 5. And for the last one, we've already picked the only yellow that existed. So we're going to pick 0 out of 5 for our yellow. Okay. What questions do you guys have about how we filled in that tree diagram?
Does it matter which color you decide to take out?
Yes, you have to pick the one that goes with the branch. Like each one is going to have a branch. And so you have to pick that one as the removed one on the next layer. So like for this little branch, I had to say that yellow was chosen first because that was the probability for this one. Does that help?
Is a branch just like that straight line?
Yeah, so this is my first branch. This is if I picked a yellow first. If I pick a yellow first, then there's 3 possible options, really 2 for this particular example. And so then I put the probabilities for after I've picked a yellow right here.
Could you
These are the possibilities of if I've picked a blue first, and these are the possibilities if I picked a red first.
Okay.
Okay, now this is pretty much because it's asking the same question. It's just saying we didn't replace the marble. And so again, if we're looking to see what the probability of getting two different colors is, there's going to be a ton, there's going to be a ton of probabilities to calculate, specifically 6, okay? I don't want to calculate all those probabilities. So what I'm going to do is I'm going to calculate the probability, and I should have written it this way on the other one, of picking a red and a red, a blue and a blue, and then a yellow and a yellow. And this ends up being even nicer than the other one, okay? Now, to calculate the probability of red, red, we go along the red branch, and we multiply it by the number that's along the second red branch. So 1/2 times 2/5. For blue, blue, I'm going to go along the first blue branch, 1/3, and then go along the second blue branch, 1/5. And for yellow,
Wait,
yellow,
what's
I'm going
P?
to B.
P.
There shouldn't be
Like
a
what?
P. There's
It's-
R's and then B's.
No, like what are you multiplying that by?
Oh, this is the probability of.
Oh, okay. Okay. I was like, what? Okay.
I'm sorry. And I should have written these guys over here like that. I should have had the probability of red, red, probability of blue, blue, and probability of YY. It's like a function. Okay. And for yellow, yellow, I'm going to have 1/6 as my first fraction. And then 0/5 as my second. So yellow, yellow should end up being 0. Because when I multiply fractions, I multiply the numerators and denominators. Here I should get 1/15. And here I should get 2/10, which you could simplify to 1/5 if you prefer. Oh, did I do that right? I think so. Okay. So then I'm going to find, so the probability of getting two different colors, oops, is going to be equal to 1 minus the probability of getting two of the same. So I'm going to do 1 minus the sum of all three of these, which is going to be 2/10 plus 1/15 plus 0. And I'm going to put that in my calculator because we're not focusing on fractions right now. So 2/10.
Was there
Plus
a point in writing the 0?
No. Just so that nobody gets confused why I didn't include yellow, yellow. And I'm going to do 1 minus that, and I should get 11/15 for my probability. Questions? What questions do you have? Okay. If there are no questions, I probably should have done this slide first. I always forget to do it first. I always do it second. This was
Can you
supposed to be
zoom
like
out
our
so we can see it?
Yes. This is our little, this is supposed to be like a demonstration. Normally I would have brought candy to class. So it says there are 2 bags of candy, one with Hershey's and one with Starbursts. A coin is tossed to determine which bag the candy is drawn from. Let's see. Layla flips a coin. Heads are Starburst, tails are Hershey's. And what are you gonna get, Layla? Just pick heads or tails, I don't care. Hurry, hurry, hurry. Layla.
I get, it's just 2 bags.
Yeah, so heads are Starburst, tails are Hershey's. Pick heads or tails.
Oh, heads.
Okay, and get heads. Okay. So then, so heads means Starburst. So then you're gonna select, pick a flavor. There's like pink, yellow, orange, red, right?
Pink.
Okay, so we're gonna do select a pink Starburst. Okay, then it says draw a tree diagram and determine the probability of this outcome. Okay, so the first thing we have to do is we have the probability of flipping heads or tails. The probabilities here were half and half. Okay. Then once, so we picked heads. Heads was Starburst, and we said that there are 4 options. And we'll use the colors instead of the flavor names, I guess. So we have red, pink, yellow, and orange. I think those are the 4 flavors. Okay. And then Hershey's, I don't know. We'll say there are 3 options, and we'll have chocolate or milk chocolate, dark chocolate, and dark chocolate with almonds. Okay, so those are going to be our 3 options. So let's see. We could assume that the bags, we're going to go ahead and do this. The bags are evenly split. So this is going to be 1/4, 1/4, 1/4, 1/4. I think that, so normally when we're in class, we actually count and we figure out what the probabilities of getting each of them are. Okay, so in our particular outcome, we're looking at the probability that we get a pink. Okay, and so first we would go along and we would say we had to get a heads first, so that probability was a half. And then we had to get a pink, and that probability was a 4. And that means that we have a 1/8 chance of getting pink. Okay, does that make sense? Hopefully that helps a little bit.
This is probably just a me question. How did you go from 1/2, then the 1/3, and the 1/4?
So 1/2 was heads or tails, right? There's a 50-50 chance of getting heads or tails. 1/4 came from there were 4 options, and we don't actually have a bag of Starburst to count. So we're going to say that we had an even probability of getting any of the flavors. And same with the chocolate.
Okay.
Yeah. If we were actually in class, we would have bags of candy and we could have actually figured it out. And we'd have a lot more time and we'd have candy and we wouldn't be giving each other viruses. Okay, so then we could practice this. So if we were in class, we would practice this with replacement and without replacement. We would try doing each option. Okay, so all right, so let's start off with just Starburst for with replacement. Okay, so we had, and I'm just going to use the letter, yeah, they're all different letters, so that works out. So 3, 4. So we have red, we have pink, we have yellow, we have orange. Okay, and we're going to say that we have, oh, well, let's pick a number. How many total Starbursts are going to be in our bag? Anybody, pick a number. Let's do one that's divisible by 4 so that it makes it